Now, Sena, let's look at a few soft examples on friction. The first question here says a force of 20 Newton applied parallel to the surface of a horizontal table is just sufficient to make a block of mass 4 kg move on the table. Calculate the coefficient of friction. Okay, this is how we answer a question like that. First thing, let me draw a diagram to show you how friction works. W is mg. Now, the mass of the block is 4 kg. Acceleration due to gravity is 10. G is 10, so that means its weight is 4 Newton. An equal but opposite force, which is called the normal reaction, acts upwards, which is the force with which the floor also pushes the box upwards. That will also be 4 Newton. This is the same because upward force balances downward force, because the box does not move into the surface and it also doesn't move upwards. So that means these two forces balance each other. That's why there's no motion in the vertical sense. Now, the force applied is what? 20 Newton. 20 Newton. And the, what's it called? Frictional force is going to be like this. The question says 20 Newton applied, calculate the coefficient of friction between the block and the table. Let's now do that. Coefficient of friction. The question says that the push P is just enough to make the block move. If the push P is just enough to make the block move, that means the push P is equal to the frictional force. That's a language we use in friction. So, and we know that frictional force is mu r. So you can write that mu r is frictional force. So mu r is what? 20 Newton. Exactly. So go back now and say r is W. Mu W is 20 Newton. So mu is 20 Newton over W. That will be 20 over 40 Newton. And that gives coefficient of friction as 0.5. Friction is easy once you know the technique. Second question says a metal block of mass 5 kg lies on a horizontal platform. If a horizontal force of 8 Newton applied to the block through its center of mass just slice the block on the platform, then the coefficient of limiting friction is, this is the same as number 1. Number 2 is the same as number 1. A metal block of mass what? Of mass 5 kg. So W is mg. W is what? Mg will be 5 times 10. 5 times 10 gives you what? 50 Newtons. The upward force is what? R, which is W, also 50 Newton. The question says a force of 8 Newton is just enough to make the block slide. So that means a force of 8 Newton, when P is 8 Newton, P equals the frictional force. So the push is equal to frictional force is 8 Newton. We'll now go ahead and use mu is frictional force over R. You understand? From mu is equal to FR. We know that frictional force is mu R. So that means mu will be what? F over R. So that gives us what? 20 Newton over 40 Newton. Okay, sorry, excuse me. Okay, it should be 8 Newton over 50 Newton. Okay, 8 Newton over 50 Newton. That's what? That's 4 over 25. So what is 4 over 25? Your coefficient of friction will be 0.1. 25 in 4, 0. 25 in 41, and that's 16. 25 in 160. Just get the answer yourself. Use your calculator to get the answer yourself. Says the answer is 0.16. 4 over 25. 0.16. Let me clean that and finish it. Okay. The remainder is 15, not 16. 25 and 156. All right. Question 3 says, a 100 kilogram box is pushed along a rough road. It's pushed along a road with a force of 500 Newton. If the box moves with a uniform velocity, the coefficient of friction between the box and the road is, okay, same as question 1 and 2. This is the same as questions 1 and 2. Box is what? Has a mass. Box has a mass of 100 kg. So its weight will be mg. That's 100 times 10. That means the weight of the box is 1000 Newton. If the weight of the box is 1000 Newton, the floor too will be acting on the box with an equal but opposite direction, with an equal but opposite force, which will be equal to what? 1000 Newton also. It says a force of 500 Newton. So let's say the push or the drag is 500 Newton. Just keeps it moving at constant velocity. So that means the push is just equal to the frictional force. Now, frictional force is mu times R. So if we put this right, mu will be F over R, because mu R is equal to frictional force, and mu will be frictional force over R. We know the frictional force as 500 Newton. The normal reaction is equal to the weight, 1000 Newton. So our coefficient of friction between the surface of the box and the road is 0.5 Newton. Now, that's numbers 1, 2, and 3. Let's look at number 4 here. I think I have number 4 first in a weird way, but it doesn't matter. So number 4 says, what is the coefficient of static friction? What is the coefficient of static friction between a load of mass 2 kg and the horizontal surface if the limiting friction is 10 Newton? So between a load of mass 2 kg, the limiting friction is 10 Newton. The mass of the load is 2 kilograms. So its weight will be equal to what? That means its weight will be mg. That's 2 times 10. Acceleration due to gravity is 10. 20 Newton is its weight. The normal reaction of the floor on the mass will also be equal to 20 Newton, like we said before. So using the equation, it says if the limiting friction, let's say you push it this way with force P, the limiting friction is set to be 10 Newton. The question says if the limiting friction is 10 Newton, that we should find the coefficient of friction. So write that F is mu R. Frictional force is equal to what? Is equal to coefficient of friction times normal reaction. So 10 is equal to mu times 20. The normal reaction is 20. So your mu, coefficient of friction, will be 0.5. Number 5 is similar. Question 5 says, a block weighing 15 Newton. A block weighing 15 Newton rests on a flat surface, and the horizontal force of 3 Newton is exerted on it. And the horizontal force of 3 Newton is exerted on it. Determine the frictional force on the block. Okay. Here we are not told that the box moved. Since we are not told that the box moves, it means that the box did not move. So 15 Newton is the weight of the box, which is acting downwards. The normal reaction of the surface on the box is also equal to W, which is 15 Newton too. So write that the applied force is 3 Newton. Frictional force acts backwards. So frictional force will also be what? 3 Newton. Since there's no motion, it means the frictional force balances the push. This one is acting to the right. Frictional force will also act to the left, but in opposite direction. To the left in opposite direction, I mean. So 3 Newton, 3 Newton will balance each other. Let's go to question 6. Okay, this is the diagram for. Okay, I think I made this as an extra explanation before. Let me clean it. since we don't need it here. Anytime you push an object with a particular force, once it doesn't move, it means that force is balanced by the frictional force or by the limiting frictional force. Now in question 6, it says a concrete block of mass 35 kg is pulled along a horizontal floor with the aid of a rope inclined at an angle 30 degrees to the horizontal. If the coefficient of friction is 0.75, calculate the force required to move the block over the floor. Okay? In this question, force required is meant to be F, although it is the component of that force parallel to the horizontal surface that will move it along this direction. Can you get what I'm saying? So they are asking us what force will be applied here on F that will be enough to move it along the horizontal surface here. So all we need is very simple. Let's get the frictional force first. The object has a mass of 35 kilograms. 35 times 10 mg will give us 350 newtons. Now, after getting 350 newtons, which is the weight of the block, it means that the normal reaction 2 will be equal to what? 350 newtons, like we said before. Now, we are told that the coefficient of friction is 0.75. So put this into the equation for friction. 0.75 is equal to what? Put this into the equation for friction. Let me clean this. Put this into the equation for friction. What do you get? F is equal to what? The frictional force F is mu R. So frictional force F will be equal to 0.75 times 350. Exactly. W is the weight, which is the same as R. So 0.75 times 350 is 262.5. Now the question says we should find the force F applied there, which will be enough to make the object move horizontally. If it must move horizontally, this horizontal component of F must be equal to the frictional force. So now we know the value of P, because for the object to just move on the surface, this P must be equal to the frictional force, 262.5 Newton. So what we want to do now is very simple. We want to find the component, we want to find the force F. We want to find the force F here, applied here, that will give the horizontal component of what? 262.5 newtons at 30 degrees to the horizontal. What force F applied at 30 degrees to the horizontal will give the horizontal component P, which will be equal to what? 262.5. Let's do that together. I'm going to change this to yellow, so I have this. I need P, which is the horizontal component. What I need is here, P. So if I need P, all I need to do is remember that cos 30 is adjacent, which is P, over hypotenuse, which is F. This is the hypotenuse of the right angle triangle. This is the adjacent. This is the side adjacent to 30. So if I cross multiply, it means that if I cross multiply, my P will be equal to F cos 30. Or I can write that F cos 30 is equal to P. So F is P over cos 30. That means F is what? F is what? 262.5 over 0.8660. 262.5 over 0.8660 will give you the force applied at 30 degrees to the horizontal that will produce a horizontal component of 262.5 newtons. Take note of that question. Let's go to question 7 now. Sorry about my arrangement. I think I started from that number before going back to number 1. Number 7 says, a body of mass 10 kg rests on a rough inclined plane. whose angle of tilt, theta, is variable. Now, theta is gradually increased until the body starts to slide. Until the body starts to slide down the plane at 30 degrees. The coefficient of limiting friction between the body and what? And the plane is what? Now, 10 kg theta, 30 degrees. Let's draw a diagram for that question. Okay. Let's draw a diagram for that question. When a body is rested on a vertical surface, like on an inclined surface, its weight W acts downward. It will have a component of its weight which is called W sine theta, which acts along the plane. Then frictional force F will act backwards like this if it tries to slide down. So here, as we can see, there's another component of the weight which is acting normal to the plane called W cos theta. Then the normal reaction of the plane on the box is also the same as what? It's also the same as the component of its weight resting on the plane. The component of the weight of the box resting perpendicularly on the plane is W cos theta. That means the normal reaction of the plane on the box too. The normal reaction of the weight of the box too, which acts upwards like this. The normal reaction of the plane on the box is also R, W cos theta. Let me say that again. Now, the weight of the box acts downwards because gravity acts downwards vertically. Can you see that? So the weight of the box will also act vertically downwards in this direction. But there's a component of the weight of the box which acts along the plane. That is called W sine theta. Theta is here. There's also another component of the weight of the box which acts perpendicularly to the box. That is W cos theta. Now, the normal reaction of the plane on the box is also acting perpendicularly upwards, and it is equal to the component of the weight acting perpendicularly on the plane. Can you see that? So normal reaction is also W cos theta. Now, if we put all these together, it still brings us to our, equation of friction, which says F frictional force is mu R. Can you see that? Frictional force in this case is mu R. Now, when the object just starts to slide down, when the box or weight just starts to slide down the plane. When the box or weight just starts to slide down the plane, what happens at that juncture is that the component of the weight of the box acting down the plane, W sine theta, equals the frictional force acting upwards. Can you see that? I can also put it like this. The component of the weight of the box acting downwards, Fr, equals the frictional force. So this is the component of the weight acting along the plane. So at the point where this one equals frictional force, the box will just start sliding down the plane. So if we put these two together now, Fr is equal to what? Fr is equal to mu R. And we know that our R is, okay, let me put it this way. We have written here that Fr, frictional force, is mu R. And we know that our R is what? Our R is W cos theta. So we can write that it means that W mu times W cos theta is equal to mu sin theta. Let me take that again. When the box just starts sliding down the plane, what it means is that these two forces have balanced each other, or this one is just about to topple this one, or just about to exceed it. So that means at the point when the box starts sliding down the plane, W sin theta is equal to frictional force. So you can write that frictional force is W sin theta, and keep that somewhere. We already wrote before too, from our equation of friction, that frictional force is dependent on the normal reaction. So that means frictional force is also equal to mu r. But we know that this r is the same thing, this normal reaction is the same thing as W cos theta. We have written it here, that the normal reaction of the plane on the box is equal to W cos theta. That means we now have two expressions for friction, W sin theta and what? Mu W cos theta. So if I write mu W cos theta is equal to W sin theta, my mu, which is coefficient of friction, is the same thing as W sin theta divided by W cos what? W sin theta divided by W cos theta. Now, W sin theta divided by W cos theta. W is the same thing as mg. So that gives me mg sin theta divided by mg cos theta. So it means that my mg can cross mg, and I will have mu is equal to sin theta over what? Cos theta. Okay, let me write that one. It means that my mu is equal to what? Sine. My coefficient of friction on the inclined plane is equal to sin theta over cos theta. So my coefficient of friction is equal to what? Tan theta. Is that clear? So in this case now, the coefficient of friction on the plane will be equal to tan 30 degrees, because the angle of inclination on the plane in this question is given as what? Is given as 30 degrees. So you find tan 30, and that will be your coefficient of friction. Use your calculator to get that. Question 8 now. Question 8 now. Question 8 says a force 10 Newton, drags a mass 10 kg on a horizontal table with an acceleration of 0.2 meters per second squared. Let's do that straight. A force 10 Newton. Let me do that straight. I will need to start drawing straight. A force 10 Newton. A force 10 Newton. So my push now is what? 10 Newton. Drags a mass of what? 10 kg. Okay, let me put the weight straight. Weight is mg. That's 10 times 10. That's 100 Newton. Drags a mass of 10 kg with an acceleration of, what's the acceleration? With an acceleration A of what? 0.2 meter per second squared. You understand? So the normal reaction will still be there, R, which is W, which will still be equal to 100 Newton like we said before. Now, frictional force, we don't know. Let me just put FR here. The question says, if the acceleration due to gravity is 10 meters per second squared, it says the coefficient of friction between the moving mass and the table is, the coefficient of friction between the moving mass and the table is, so here now we are looking for frictional force. Now, this is another new part of friction. In all the questions we've done, what we have done is that we have only worked with the mass when we have only worked with the motion of the object when the applied force is just equal to the frictional force. So we have only been working with P is equal to FR. But in this case now, there is a net force. You understand? Because the body now gains an acceleration, it doesn't move with constant velocity. Whenever that happens, the equation we always use is that the excess between P and friction is what will be the net force, which will give acceleration to the mass. That's the technicality in this question. The difference between the applied force and the frictional force is what gives acceleration to the object. So that means P minus frictional force is equal to what? Net force. So that means P, the applied force, minus frictional force is equal to what? MA, because it is the net force that gives acceleration to the mass. So let's now put this in our question. The applied force is 10 Newton. We don't know frictional force, but we know the mass as 10 kg, and we know its acceleration as 0.2. So we can easily get our frictional force. Are you getting what I'm saying? Let me try and explain this again. If a box is say 50 kg, and I'm applying a force of 100 Newton, and the frictional force is what? 80 Newton. If I want to find the acceleration with which this box will start moving, it's very simple. You understand? Which one is bigger between these two? Frictional force is pulling it this way. FR. My applied force is pushing it this way. 100 Newton P. P is equal to 100 Newton. This one will definitely overcome this 80 Newton. Can you see what I'm showing you? 100 Newton will overcome 80 Newton. So it means that the object or the box will start moving to the right with force F net. The net force acting on it will be P minus frictional force. So the net force acting on the mass will be equal to what? 100 Newton minus 80 Newton. 100 Newton minus 80 Newton is 20 Newton. So the net force that will be acting on this mass will be 20 Newton. If I now want to find the acceleration, I just use F is equal to MA. In F is equal to MA, the net force is 20 Newton, the mass is 50 kg, and the acceleration is A. So 50A is 20. My A will be 20 over 50, and I get my answer. Can you see that? That's how we find, acceleration of an object when the force applied on it overcomes friction and it gets an acceleration with which it starts moving. Are you getting what I'm saying? Let me give you another example. This is a very important part that you must get very well before we proceed. Let me give you another example. Let's say I have a mass of 30 kg on this surface, rough surface. Mass of what? 30 kg. So I'm applying a force of let's say I'm applying a force of 70 Newton. This is my P, applied force, 70 Newton. Let's say the frictional force, FR, is what? 45 Newton. What this tells you is that definitely 70 Newton is pushing it to the right. Frictional force is, dragging it backwards to the left. It means 70 Newton will overcome frictional force. So it will end up moving in this direction with an acceleration A. Now, for you to know that acceleration, you need to know the net force with which it starts moving, the net force acting on it when it starts moving. That net force acting on it will be equal to F net, which is P minus FR. So the net force acting on it will be what? Will be 70 minus 45. The net force acting on it will be 70 Newton minus what? 45 Newton. So the net force is 25 Newton. So using F is equal to MA. If you want to find the acceleration with which it starts moving, your MA will be equal to F A will be F over M. That's what? 25 Newton over the mass of the object, which is what? 30 kg. So that's how we find acceleration when an object is, acted upon by two or more forces that are in opposite directions. So I think that is very clear now. Let's now go back to our question. Excuse me, I have to clean all this. They are not part of our question. So let me just clean everything. Very important to quickly do that by the side. So in this case now, the applied force is 10 Newton. The frictional force is Fr. And we are given the acceleration and the mass of the object. So we do 10 minus Fr is what? 2. 10 times 0.2 is 2. So that means 10 minus 2 is frictional force. And the frictional force is equal to what? 8 newtons. So it's as simple as that. The frictional force acting on the object is 8 newtons. That was what question? I think that was, it says the coefficient of friction between the moving mass and the table. Okay, I think we are not done yet. We know the frictional force, but we actually need coefficient of friction. So we will still do frictional force is mu r. In this case, 8 newton will be mu times what? W. R is the same thing as W, so that's mu times, what is the weight? Okay, 100 newton. Mu times what? 100 newton. So the weight is 100 newton. It means weight is 100 newton. Let me show you that very well here. The weight of the object is 100 newton. The weight is acting downwards on the surface. The normal reaction to will be 100 newton. You understand? Like we said before. So I have my answer now. 8 is equal to 8 newton is mu times this. So 100 mu is 8. Newton crosses newton. 100 mu is 8. Mu is 8 over 100. Mu, which is the coefficient of friction, is 0.08. The coefficient of friction between the surface and the box, between the base of the box and the surface of the table, is 0.08. The question 9 says the coefficient of static friction between a 40 kg crate